Good afternoon, Algebra 2 students. I'm sorry I'm not there today. I guess it's my turn to not feel so well. But today I don't want to hold you up in your lessons, so I wanted to go ahead and at least record these videos for you so you could still work on math today and we could still continue to progress toward where we need to get to. So let's look at 92. We're going to be talking about boat and the river problems. So when you think about a boat, I think about a couple different things. First of all, we know that in water, there's always a current, right? So in these little pictures of water up here on the top of your packet, kind of shows the waves are kind of curling to the left there. So it tells me the current there is kind of heading to the left. The current then causes anything you throw in the water, right? The current's going to take it downstream. It's going to follow with the current. So if we have a boat that's in the water, it's a sailboat, but it has a motor on it. We'll say it has a motor there somewhere. That boat could be doing three things depending upon what the boat's doing. So if we have a current here, and that current is heading downstream, we'll say this is downstream, and we say the current travels at a certain mile per hour. Let's say the current goes at 3 miles per hour, for example. That boat, if the motor is not turned on, that boat is going to float with that current at 3 miles per hour downstream, right? Now, if I crank that boat and start it and continue to head downstream, and my boat is going to go 11 miles per hour, so let's say the boat travels at 11 miles per hour, that boat's going to go a little bit faster than 11 miles per hour because it's going to go the 11 miles per hour it travels, plus the current adds to that 3 miles per hour. So that boat is actually going to be traveling at 14 miles per hour if the motor is on downstream. Now let's say it turns around and wants to head upstream. Okay, now when you go upstream, you're going against the current. And against the current would be, you're going to have to deduct what your rate's going to be. So the boat can still travel at 11 miles per hour, but since you're going against a current of 3 miles per hour, you're going to have to deduct 3 miles per hour off of your 11, and that would mean that upstream you would actually be traveling at 8 miles per hour, okay, because you're fighting that current. So there's a couple little formulas that help us to keep this straight, and those are written at the top of your packet here. So if you're going downstream, B represents the boat. It says right up here, you can see here. B represents the boat, and C represents the current speed. So you take the boat plus the current downstream. That's how we would represent that. However fast your boat's traveling plus the rate of the current will give you the rate of the boat's travel. Okay, if you're going upstream, it's going to be just the opposite. You take whatever the boat is traveling, but you're going to subtract for the current. And that's as easy as that. So let's look at an example here. Number one, these look like names from some of the students last year. Christy and Emma could go 60 miles downstream. In the same time, it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? All right, perfect. So we get a picture of these girls in their boat. We know they can travel downstream at 60 miles per hour. And in the same time, if they turned around and went upstream, they can only go 20 miles per hour in that same time. So we know time is going to be the same. Okay? If the speed of their boat in still water is 8 miles per hour, so provided that there's no current, it's just completely still water, the speed of that boat would be 8 miles an hour. That's the rate of the boat, okay? What was the speed of the current? This is what we want to find, the speed of the current, and what were their times? Those are the two pieces of information we want to pull out of this. Now we're going to use our formulas from up here. Since we have something to represent both downstream and upstream, we're going to go ahead and put down here and up here to represent downstream and upstream. Okay, so the rate for downstream, remember where we get that, that's up top here. Let me highlight it again. Upstream is B plus C, remember, and downstream is B minus C. So the rate, we're going to go ahead, I'm going to put a capital B here. So we have downstream is B plus C and upstream is B minus C. And we're dealing with both of those. We're talking about these girls going upstream and downstream. So we need both of those in there. We know the distances. The distance downstream was 60 and the distance upstream was 20. Okay, so from there, we're going to set up a system of equations. Now, this is not going to be like a distance. We're not setting distance equal to distance, obviously, because our distances are different. Distance upstream is 60 miles. Distance downstream is 60 miles, and distance upstream is 20. So we're going to set up a system here. Now, do I know what do I know what B already is? Let's go back and find that. We're told right here that the speed of the boat is 8 miles per hour in still water. So without adding the current to it, the boat alone is 8 miles an hour. So we're just going to go ahead and cross these out. Let me make this a little bigger here. We're going to put an 8 here. The boat is 8. So we're going to take 8 miles an hour and add the current to it. And then we're going to do the same thing for going upstream. We're going to take 8 miles an hour and subtract the rate of the current. So let's go ahead and figure out our system here. So let's set up 8 plus C is going to be multiplied by time, right? Because remember, this is always rate times time still equals distance. So I'm going to write out 8 plus C times time equals 60. And below it, 8 minus C times the time equals 20. Alrighty, so let's solve these now. Excuse me. Excuse me. All right. Okay, so let's pull these out here. We're going to go ahead and distribute those. So we're going to have 8t plus ct equals 60. And here we're going to have 8t minus ct. And this is going to work out beautifully because you see I can eliminate right here. So now I have 16t equals 80. And if I divide both sides by 16, I end up with t equals 5 hours. Okay, that's the first part of this. Now the second part of this, that was the first part. We figured out the time is 5 hours. Okay, second thing, hang on 1 second, I just want to read one quick thing here. Times. Okay. All right, so it took them 5 hours to go downstream and 5 hours to go upstream. So number 2, we need to figure out the second part of this, which was the speed of the current. So now we're going to solve for C. So we can take one of these. We'll just take 8 plus C times T equals 60. Just grab one of those above and fill in what we have. We have time now, which is 5. And we're going to have 40 plus 5c equals 60. Subtract 40. 5c equals 20. I'm going to write that up here. We divide both sides by 5. And c is going to equal 4 miles per hour. That's the speed of the current. So that's how you do this. They're really quite simple. Let's look at number 2. The water in the Caloosahatchee River is flowing at 5 kilometers per hour. Wyatt can cruise in his boat at 15 kilometers upstream in the same time it takes him to go 25 kilometers downstream. How fast is Wyatt cruising in his boat in still water? So how fast we want to know. Okay. Also, was there one other question? How fast is Wyatt cruising in his boat in still water? Okay, no, just one thing we need to find. All right, so we're going to represent our downstream and our upstream again here because both of those are mentioned. We know the formula is B plus C and B minus C, right? Rate is what we're trying to find here. The time is, let's see. Why is bed if it's in the same time? Oh, we don't know time. Okay, so we don't know our time, but we do know our distances. We know he goes downstream at 25 kilometers and 15 is his upstream. Okay, so you take your parts out of there and plug it in. So the water in the Caloosahatchee River is flowing at 5 kilometers. So we do know the current. The current is 5. So we're going to put 5 in for our current. And we're going to solve for our time. And our time is going to help us figure out how fast Wyatt was cruising in his boat in still water. Okay, so let's go ahead and set up our system. So we have B plus 5 times time equals 25, and B minus 5 times time equals 15. Let's go ahead and distribute this out here to the right. So I'm going to have BT plus 5T equals 25. And I'm going to have BT minus 5T equals 15. Okay, now since I'm going to be solving for time here, I want to get rid of one of these variables. I'm going to try to get rid of the B variable, because it looks like you're probably looking and thinking, well, I can eliminate this right here. But when you do that, you're going to be left with these two variables. So it's probably not the best method to use. So let's multiply this top one all by -1. And then I'm going to come down here and write what happens. So I'll have a negative BT minus 5T equals negative 25. And then we'll put the second one below it, because really and truly, this is what we want to get rid of right here. So now I have negative 10T equals 10. Negative 10. Divide by negative 10. T equals 1. Time is 1 hour. Okay, now they didn't ask for that, but we need that to find the next part of our equation. So let's go ahead and take one of these equations from up top. I'll grab this one right here and write it BT plus 5T equals 25. And I'm going to go ahead and substitute in my 1 that I got for my time down here. So B times 1 plus 5 times 1 equals 25. We'll subtract this 5 from both sides. So you're going to have B equals 20. So 20 what? Kilometers per hour? Oops, KMP. Okay, kilometers per hour. There we go. So in still water, Wyatt's boat would go 20 kilometers per hour, and that's how you would solve that. So let's move into the practice set. We'll do a couple practice problems together and see how we make out. This is going to be on your page 384. All right, so let's read it. Annie and Patrice could go 50 miles downstream in the same time it took them to go 30 miles upstream. So far we see the same time. Let's go ahead and put our downstream and our upstream here. And we're given the distances that they traveled, 50 miles downstream and 30 miles upstream. Perfect. If the speed of their boat was 4 miles per hour in still water, what was the speed of the current and what were their times? Okay, so we know that downstream the rate is always B plus C and upstream is always B minus C. What the boat can travel plus the current for downstream, and what the boat can travel minus the current rate of speed on the upstream. So here we're given some information. So I'm going to change one of these here. What are we given? The speed of the boat is 4. So we're going to cross this out and make this a 4. Now we have something to work with. So let's make our little system down here. So I'm going to have 4 plus C times T equals 50, and 4 minus C times time equals 30. Let's go ahead and distribute those out. 4T plus CT equals 50. 4T minus CT equals 30. Now in this case, we can go ahead. We have two variables, C and T together. So if we get rid of those, now I'm left with only one variable, which is T. So we have 8T equals 80. Divide by 8. And your time is 10 hours. Now, is that all we're looking for? No. We want to also know what was the speed of the current and what were their times. Okay, so the time is 10 hours. But we need to figure out the speed of the current. So what was the rate of speed or the rate of travel of the current, the water? How fast was the water moving? So let's figure that part out. So we're going to go grab another one of our, let's see where I can write this, I guess right below. I'm going to come over here. This was our first part, and here's our second part. I'll just number them to keep them straight. So I'm going to grab the first equation up here, 4 plus c times time equals 50. And I'm going to go ahead and put in there 10 for time. Let's distribute that. 40 plus 10c equals 50. We'll subtract 40. You end up with 10c equals 10. We divide by 10. You're going to end up with the current is 1 mile per hour. That's as fast as your current is moving, 1 mile per hour. So that's how you do that one. Now, if you'd like to pause the video, try this one on your own, come back and check it and see if you did it correctly. That would be great. Then you can see how well you understand this. The sloop Zolly could go 33 miles downstream in 3 hours, but required 4 hours to go 12 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? All right, perfect. So let's write our downstream, our upstream, our little formulas here that we know, the boat plus the current for downstream, and the boat minus the current for upstream, because you're fighting against the current. Now let's grab some parts of this story and put it into our graph here, into our chart, our table. Okay, he could go 33 miles downstream. That's distance, 33. Let's see, and that was 3 hours. We were told the time as well. But it required 4 hours to go upstream 12 miles. Okay, so we have a lot of information we can fill in and use here. So let's set up our system. That's the first thing. So we're going to use B plus C times 3 equals 33. And B minus C times 4 equals 12. Let's distribute this. We have 3B plus 3C equals 33. And we have 4B minus 4C equals 12. All right, now this was a little bit more complex because we have to, I don't see anything to eliminate here, so I have to change both of these into something that I can use to figure out how to eliminate. So I'm going to multiply the top one by 4. Let's see what we're going to do. If I multiply the top one by 4 and the bottom one by 3, what's that going to change for me? That's going to make this right in here. It's going to give me the ability now to eliminate those. So down below, let's go ahead and make that calculation. So here's going to be step 2. I'll put 2 here. Okay, so we're going to have, if I multiply the top one by 4, I'm going to have 12b plus 12c equals, and 33 times 4 is 132. And on the second one, I'm going to have 12b minus 12c equals 36. If I go ahead and put those together, let's see, I can eliminate these, and I'm going to have 24b equals 168. If I divide both of those sides by 24, I'm going to end up with 7 hours. So the boat let me see what they were asking. What was the speed of the boat in still water, and what was the speed of the current? Well, you know, I think I could have just taken the time and plugged that in, couldn't I have? That was kind of a lot of work to find that, but let me look at something here. Okay, well, anyway, it's good to process it in case we didn't have both the times, but I'm looking up here at the times, and we know that they traveled 7 hours total. So I could have just known that and used that in one of those formulas to figure out the current's rate, because that's what we're trying to figure out. What was the speed of the boat in still water, and what was the speed of the current? Oh, I'm sorry. No, wait a minute. I'm sorry. Wrong. Oh, help me. Okay, not hours. That isn't even what I solved for. The boat, it's the speed, 7 miles per hour. There we go. That makes me feel a little better. Okay, so 7 miles per hour, not 7 hours. Oh, great day. All right, number 3. All right, so number 3, let's take our formula. One of the two up top there. We'll just grab the first one because it seems like it's easier than I always like adding better than subtracting anyway. So I'll just grab that one. Let's put the speed of the boat in there, not the time of the boat, the speed of the boat. So 21 plus 3c equals 33. We'll subtract 21. 3c equals 12. Yep. 3, and c equals 4. So the current is going 4 miles per hour. The boat's going 7 miles per hour. And that's the answer to that question. Sorry for that little flub up there. Okay, guys, that's the first lesson. I hope that makes sense to you. They're really not that bad. Just pick them apart. Use the table. The table is wonderful. And I'll see you on the next